All right. Welcome to Cpp.chat. We've got what I think is going to be a great episode. We have two guests who've never been on before, and we will introduce them shortly. We also have our producer, Phil Nash, who has now, this is the fourth episode of our rebooted Cpp.chat. Is that right, Phil?
I believe so, yeah. We're actually up to episode 28 because we're continuing your initial numbering scheme.
Okay. So our guests today include Arthur O'Dwyer. Arthur, you want to introduce yourself and say a little bit about what you do?
Okay, that means you don't have to introduce me, huh? I'm Arthur O'Dwyer. I do a lot of speaking about C++, particularly at CPPCon. I was at C++ Now this year. I wrote a book called Mastering the C++ 17 STL. Yeah, I'm semi-active on the committee, not really. Yeah, I don't know.
And you're giving a class at CPPCon on the standard library.
Yes, and that, what John said. Giving a class at CPP.chat. Highly recommended.
Yes, excellent. All right. Our other guest, also a first-timer on the show, is Simon Brand. I have been using Simon's famous tweet about East Const and West Const in my lightning talks recently. We didn't tell Arthur this, but the truth is we just got him on the show to gang up on him because he's outnumbered.
I didn't even wear my West Const.
Yeah, I didn't wear my East Const ones. So.
That's not for the best. All right, Simon, introduce yourself and tell us what you're known for other than East Const.
Yeah, so my name's Simon Brand. You might know me from the internet as Tartan Llama. I'm a senior software engineer at CodePlay, where I work on compilers and debuggers for heterogeneous systems like OpenCL, GPU compilers, things like that. I run my own C++ blog at tartanllama.xyz. I write and co-author a few standards papers, but I have kind of minimal involvement there. And yeah, I'm very excited to be on the show. And recently I've also been amazed at how quick Arthur has been getting out great blog posts. It seems like every week or something you've got something new out, and they've all been really great.
Thank you. Yours too.
All right. So our topic today, well, I guess we should probably do a little bit of kind of news roundup, which is what we normally do here. We've got C++ Now just wound up. Videos are starting to go up. Trip reports are out. So if you want to see the videos or the trip reports, go to cppnow.org. We're getting those things up now. Slides are going up. We don't have very many slides yet, but those are going up. Have you got your slides in, Phil?
I have not.
Neither have I, so. So we're both guilty of that. But we'll get those in, promise. And CPPCon, we've got the, we just got the, we have, today is actually the deadline for doing CPPCon submissions. If you went to C++ Now, we actually extended the deadline for people who went to C++ Now. We also have, for people going to CPPCon, the lodging page is up, so all of the hotels that you can go to. So that's the news there. But we have another conference that's coming up that was just recently announced on CPPcast. Speaking of CPPcast, Ben Craig is their guest this week, and they actually talk a little bit about the proposal that we're going to talk about today on the show. I haven't heard the whole show, but I've heard about half of it so far. And so it sounds like a good show. But last week on that show, someone announced a new conference. Do you want to tell us a little bit about that, Phil?
Yeah, I could do. So I probably should have announced it here first, but I'm actually going to be running a conference of my own. It's called C++ on C. It's going to be in the UK next year, next February. I don't have the exact dates in front of me, but I believe it's the first full week in February. And it's actually going to be by the sea, hence the name C++ on C, SCA. In fact, the venue is built into the cliffs overlooking the English Channel. So you have a view of the sea from three sides. on a clear day, you should be able to see across from France. And in fact, it's very well connected with the rest of Europe because you have the Eurotunnel on the doorstep. So you've got direct routes from Paris and Brussels and now Amsterdam. In some ways, it's actually easier to get to now than London from certain parts of Europe. So really excited about the venue. It's going to be a 3-day conference. That's two main conference days of the conference talks and one workshops day. And it's going to be 3 tracks. So positioning it as an international conference. So already getting lots of interest from speakers, even though I haven't actually opened the call for papers just yet. I was hoping to have done that this week, but haven't got around to it yet, but hopefully in the next week or so.
But you did announce keynotes, right?
I did, yeah. We got 2 keynote speakers lined up. Really pleased to just say that we got Kate Gregory and we got Matt Goldbolt. So it sort of feels like a real conference already.
Yeah, yeah. Well, you got some good headliners there, so that will help. And of course, as they mentioned on CPPcast, you go to a lot of conferences, so you've probably met a lot of speakers.
Yeah, well, that's sort of what I'm relying on.
Yeah. All right. Well, we'll follow as you have more announcements on that. If somebody is itching to submit, is there a channel? Do you have a Slack channel for?
No Slack channel yet, so we should add that. But there is a website.
Okay.
It needs a bit more fleshing out, but you can go there. It's cpp.chat.uk, and there is a big button on there right now that may change in the next week or so. Just says register your interest. So you can just, if you just want to follow updates, or if you want to register your interest as a speaker or a sponsor, you could put all of that there. I may have to change that or take it down by the GDPR deadline, but one way or another, well, that will be sorted soon. But for now, you can use that to register your interest, no matter what that is.
Okay. All right. So I think that the big news is in the latest mailing for Rapperswil. There's a proposal in there from Herb. It's written by Herb, but it's based on work done by a lot of people. There's a lot of people who've seen this. In fact, I guess this paper was passed around in SG14. Is that right? I think both Arthur and Simon said they'd read it when Herb was passing it around then. And it was based on a lot of work by Niall Douglas to make it possible. But Niall was looking at it kind of from the library point of view, and what Herb is doing is he's making it a language idea. And I want to say that I think this is probably the single most important thing to come along since C++11. I think this is a very, very important proposal. And the reason I say that is because, you know, I kind of, the first real talks I did in public were about exceptions, and my exception safety talk, which is very, very long and very detailed and has lots of stuff in it. And one of the things that was frustrating for me is I was advocating that people use exceptions, but people would have legitimate use cases where it didn't make sense in their environment to do that. And I wasn't going to make the position that you should always use exceptions. I think the position that I gave was that I think a lot of people weren't using exceptions for the wrong reasons. In other words, there was a lot of fear, uncertainty, and doubt, and it wasn't, exceptions should be used more broadly than they were. But I couldn't make the statement that everyone should be using exceptions because there's overhead there that just isn't acceptable in some environments. And C++ has to be a language that you can use in any environment, including ones where exceptions don't work. So here we have a language which, in order to signal errors with constructors and operators, you have to use exceptions. Exceptions are the standard blessed way of doing error handling in C++. And yet, very large numbers of people, for good reasons, won't use them. And so we end up with this really terrible situation. And this proposal by Herb is trying to find a way, and I'm just going to call them static exceptions, but trying to find a way of bringing the overhead of exceptions down such that they can be used by people who traditionally have said exceptions are too problematic. And I'm going to ask Phil to explain the details as an overview of what the proposal is, and then the four of us can kind of comment on our thoughts on this proposal.
You want details or overview?
Well, overview.
We'll start with the overview.
But tell us, tell us how it's implemented, because that's what people, we're engineers. We want to know how it's implemented. Now, we don't need a lot of details, but give us the overview of how it's implemented. What exactly are we talking about here?
Yeah, we'll dig into the details, but a little bit of background first. Before we had exceptions, of course, we did error handling using techniques that we still use today, typically returning Booleans or integral error codes, sometimes passing by reference as an out parameter. So those techniques are still in common use today, despite the fact that we have this blessed facility in the language of exceptions. So, why do we still use those other techniques today? And the recent trend over the last couple of years, and this is one of the reasons in particular I asked Simon to come on, because I know he's been active in this area, is this it's come to be known as ADT-based error handling, where you actually return an object that contains either the thing you wanted or some sort of error object. And modern language and library features make that more possible now than it used to be. So it's still philosophically like returning error codes.
Variant, you mean?
Yeah, so a variant is an example of an ADT. So ADT just stands for algebraic data type, which is just sort of a bit of a mathsy way of talking about an object that can represent one of a choice of types. So variant is one example. Stood optional is another example, because it represents either the empty state or an object of some value. And then we have a more specialized form, which is still at proposal stage, but a little bit further along, which is stood expected, which represents either the object you wanted or an error code specifically. So a lot of people are using this, and one of the main reasons is the performance, particularly on the error path, which really sort of drops off a cliff. I've heard figures sort of 10, 100, maybe even 1,000 times slower than the happy path, depending on exactly where it comes up. So we've been hearing for years that you should only use exceptions in exceptional circumstances, which sort of makes sense. And part of the problem is it was all tied up in that name, because often we want to communicate errors in non-exceptional cases, but we still need a consistent error handling approach. And you mentioned, John, constructors and operators as being particularly problematic if you're not using exceptions, plus the fact that the standard library uses exceptions quite liberally. So we need some way to unify these universes to give us a not necessarily a single, but at least a cohesive approach to error handling. So Herb's proposal, or calling it Herb's, although it is built on the work of several people, is really about taking what we call the ADT-based approach to error handling, as you might write it manually, and then sort of baking in what you might consider syntactic sugar into the language to make it look a lot more like exceptions as we know it today, but with the performance characteristics of the error codes, the ADT-based error handling. And also because it's baked into the language, it gives the compiler more scope to optimize even further. There are certain registers or even bits in registers that are actually available that can be used to communicate whether it's an error or not, that can improve the performance on its own, but also frees up having to use types that prevent certain forms of moves and copy elision. So we get the full benefit of the optimizations of the language that we might use otherwise, without all of the current downsides of exceptions. And another advantage is it does potentially gives us marked propagation, which means you can actually see in the type of the function, or at least the signature of the function, and potentially at the call site, depending on which option is selected, where exceptions can propagate from and to. Although there's a little bit of controversy around some aspects of that at the moment, which I'm sure we'll dig into as we get more into the details. But I think that's the background. So let's pass it back.
All right. So I guess one of the things that is fundamental to all of this is the observation that the cost we've seen, the overhead with exceptions is because of the fact that exceptions could be of arbitrary type. So I'm throwing something, I could throw absolutely anything. And so only at runtime can we really try to figure out what is this and try to do catches based on what the runtime value is and all that kind of stuff. So essentially what we're trying to do is we're trying to pull this in and constrain it. So you can't throw just anything. When you throw, you're going to throw a specific type that the compiler is going to understand what the type is at the time that it's compiling the code. So there's no, so it can be done on the stack. We know what the type is, and we handle it from there. So I'm very excited about this. Arthur, you want to knock it down?
Sure. Although maybe I'll start by doing that from the. You asked Phil to explain it from the ground up, basically, and I guess I would also like to see it from the ceiling down, where sort of the way I think about it is we've got functions that throw exceptions, and they can throw absolutely anything, and because they can throw anything at runtime, that involves runtime type checks, like essentially a dynamic cast, involves memory allocation, so that you have enough space for whatever arbitrary object you're throwing. It can be arbitrarily large, so you need memory allocation there. And so this is a new syntax where Herb is proposing that you annotate certain functions. You can annotate them with throw or throws, which means it's not no except, but it also promises not to throw classical dynamic exceptions. It only throws the static type. And then that syntax, marking your functions that way, enables the compiler to do this extra optimization to turn it into something implemented in terms of the expected type. And looking at it that way means that you have to come up with some sort of story around how this interoperates with the existing syntaxes, right? How to throw annotated things, the static exception things, how do they interoperate with dynamic exceptions? How do they interoperate with no except? That I think, they've got a story there involving automatic translation last time I looked of static to dynamic and vice versa. I think I am skeptical of that, but there may be other stories that you could tell there, like maybe the compiler can detect and just disallow converting a dynamic exception to a static exception or vice versa. But this is adding basically a third kind of function to the language. We've got two kinds right now, no except and dynamic exception. And this is adding a third kind that doesn't behave like either of them. And we're going to have to sort of shoehorn that.
Like both of them.
What was that?
I said it behaves a little like both of them, right?
A little, yeah. That's Herb's scope, is that it behaves performance-wise like no except and functionality-wise like dynamic exception.
Right.
Unfortunately, it doesn't act like either of them.
But it seems to me like the translation could be made. If you have a dynamic exception thrown, then you've already kind of allowed, okay, so performance is not, if you've allowed a dynamic exception, then you're not going to get static exception performance. But if you have a dynamic exception, there's two possibilities. Either it is this new, I guess we haven't talked too much about it, is that there's a type std error, which is essentially an error code, but could have other data. There's restrictions on what you can do with it, but but you can think of it as just an error code. So if the dynamic type that I'm throwing is convertible to this error, std error, then it can in fact be caught with anything that's going to catch std error. But if it can't be, it's fine. We have catches like that now. You try to catch an int and it's not an int. Oh, we ignore that catch and we go to the next thing. So it seems to me, I'm not sure why it would be difficult to, I didn't read it that closely because it's like, okay, that just makes sense to me. It never occurred to me that that would be a sticking point.
Well, you need to have somehow in the in the ABI of this function, like in the calling convention of this function, it's going to be returning, it's something like an expected of t and std error, which, as you say, is like an error code. I think Niall might disagree with that contention. It's like an error code, but it fixes all the problems with error code, right? It's small and trivially copyable and context screwable and all these things. But somehow the function that called that, the caller has to know to expect this new result. It's going to be in some register or something. It has to know where to look for this exceptional result.
Sure.
And then the callee has to make sure that if a dynamic exception is thrown, it doesn't wind up going through the classical stack unwinding. It needs to make sure that somehow that result gets into this register, so that the the caller knows where to look for it. So there may be some translation happening at these.
Yeah, there would have to be, and I guess what I'm thinking is that and that is not going to be, that translation is not going to be as efficient as the static exception. However, the premise that you're starting with is that you had a dynamic exception in play. So you've already not going to get that kind of performance. So the translation, yeah, it's some non-trivial work maybe going on, or maybe not non-trivial, but I mean, it's going to be a little bit of overhead. But you've already got, you've got a dynamic exception in play.
That's fair. Although the translation also goes the other way, right? If I have a static exception propagating, and then it goes through some layer of my stack that was written, prior to 2020 or whenever this comes in, that's going to be using dynamic exceptions.
But again, that's trivial. You can take a static exception that is it's just an STD error and make it a dynamic exception.
I guess what you probably don't want to be doing is have some kind of layer cake of static and dynamic exceptions where you're doing multiple stages of translation between the two for different interfaces. Maybe I have some library which I'm calling, which is, hey, brand new and cool and uses static exceptions, and it's great, but this is getting statically thrown through my application code, which is not using that. And then something further up the stack that's implemented with static exceptions as well, and now we have to translate back. That sounds like it could be a real world problem.
It's definitely not something you would want, but I don't think it's that bad compared to what we currently have.
Yeah,
I think it's still potentially a slight improvement, and it's more of a transitional thing as we start to move more things that we want into the new world. So it's not optimal, but I wouldn't consider it a problem as such.
Well, I would say that it's only going to be a problem in a situation where you already are allowing for dynamic exceptions to happen. So, I mean, this is the way
I don't think the translation cost is that high either, because the std error actually has a slot to hold a pointer to a dynamic object that you could put an exception pointer into. You already got a dynamic exception. You just put it in that slot. You pass it down. It's not really any significant extra overhead, not compared to the cost of the dynamic exception itself, as John said.
Yeah.
Maybe that works out. I mean, I was worried originally, before there was room for that exception putter, there was this idea of actually translating the exception type itself. If you throw if something from std regex says the regex is malformed and throws a regex error, and then that somehow gets translated into one of the std erc values from POSIX to say invalid art or something, you lose a lot of information that way. But if you're allowed to just take the exception and wrap it up.
Are we worried about performance when we're using std regex?
Well, no, but we're worried about understandability.
I know what you mean. Yeah.
I mean, is this thing usable? If the answer is, now it makes everything really confusing. That's a downside.
One thing the standard could do is, there is a hierarchy of STD exception, derived classes from STD exception, and there part of the definition could be, by the way, if this gets translated into a static, this is what the error code for this exception is.
I think that was more the original direction, and to the extent that it's moved away from that, I'm happy. I mean, I don't like big lookup tables of things.
Yeah.
I'm not sure how much movement there's been there. As far as I remember, that's still on the table, the idea that you can translate a certain number of well-known existing dynamic exceptions into error codes. But I think it's not a one or the other. I think you can have both. You can have the error code represent, say, bad alloc, and you can have the original bad alloc as a pointer.
Yeah,
stored in there as well.
I'm looking at the proposal right now, and it says if the dynamic exception is of type error, then it's just returned. Otherwise, it's translated to an error with a meaningful value for all std exception types. For example, bad alloc would be translated to std rc enomem.
Yeah.
Otherwise, we could additionally store as a payload to a raw pointer to an exception pointer.
Yeah.
So one of the things that I liked a lot about the paper, the paper's interesting to read because it takes an overview. It's not just, oh, here's this cool proposal and figure out why it works or whatever. I mean, he starts out with an awful lot of introduction to the world as we know it right now. And what I liked about it is that I agreed with all that. So it was really smart. But one of the things that he called out is something that's bothered me about the exceptions in standard exception. We actually have something that's called STD logic error. And to me, that's saying somebody didn't get it somewhere, because you shouldn't be throwing logic errors, right? I mean, that's not exceptions. Exceptions are for runtime errors. And if it's a logic error, that's time to abort. That is not time to throw an exception.
Yeah, and I think that's addressed in the paper as well when he talks. There's a section about contracts, I think.
That's right.
And that goes to say, yeah, pretty much what you said. Like, if a programmer's made a mistake which isn't recoverable, then there's no point in throwing an exception. You just throw your hands up, go home.
Yes, and so I like the idea that we're recognizing that STD logic error or STD bounds error or any of these things that are essentially logic errors, things that the programmer could have tested for. If the programmer could test for it, then it's a logic error if that happens. And it's a precondition violation. And that should not be, that's not a runtime error and shouldn't be thrown.
I have a blog post about this back when Herb was circulating the paper, and he brought this up. And I sort of agree, intuitively, I want to agree that logic errors, like as Herb said, are themselves a logic error. There's no situation in which you'd really try to catch this error and do something about it. But I think in practice, the waters are a lot muddier than that, partly because a lot of things in the standard that are called logic errors are not logic errors. You mentioned bounds checking on things like std vector. The at method does bounds checking. And you might say, well, the user could check for that, right? You just put if it's in range, then call vector at with the correct index, and otherwise do whatever you would have done if you caught the error, right? And then you don't need at to throw an error anymore. But like, isn't there a reason that vector at throws instead of just having undefined behavior or a contract violation? Or like, people might actually be using that.
Right, but in that situation, I mean, the rules are essentially different. The rules are saying that is not a precondition violation. It's not a logic error because the assumption is that that it has a wide contract. You can give it anything you want and it will behave appropriately, where throwing an exception is an appropriate behavior. So it's not a contract violation because the contract for that particular call is different.
Right. And then
it's kind of silly, but I mean,
you can have both.
Right.
Yeah.
Like future, for example, future or promise set value throws future error if the value's already been set, maybe by another thread. And that's part of its contract. That's part of what it does, is it has a wide contract and it always either sets the value or it throws future error, even though future error derives from logic error. It's saying you tried to set the value twice. You clearly have some sort of issue with your program's control flow. But still, we're going to define the behavior in that case we're going to throw.
Right. I mean, whether or not something's a logic error depends on what you define. If you don't put any documentation on your code, then it's impossible to know what the preconditions are, because if you you know, if you're trying to find the square root of a negative number or trying to find the square root of a number and somebody gives you a negative number, unless you've documented it, it's not clear, is that a wide contract that you expect to handle in some way, or is that a narrow contract where they violated the precondition? I mean, there's no way you can look at the code and make that decision. You have to have it defined what that is.
Yeah, like intuitively, I agree with the things you're saying. I'm just saying that they're like in any specific case, whether we're looking at vector add or set value or any case you think.
Well, and I would go even further.
It's going to be hard to undo that and untangle it.
I used to work on Microsoft Office for the Mac version, and that's a kind of a different world than what we're used to now, where we download software that's updated every week, or it's on our phone, it's maybe updated automatically. This was something where we put some software in a box and we shipped that box, and people used it for 2 or 3 years and maybe never updated their software because that was a big pain. And in that situation, this is one of the things that we did. We would detect a logic error and say, okay, this is a logic error, but rather than aborting, we tried to sweep it under the rug. In other words, we tried to recover as gracefully as possible. And the reason is that we were going to have millions of users using this software, and they were going to use it for years. And we needed it to be as resilient as possible. So we essentially did both. When we would assert, hoping to catch it in debug, but if we didn't catch it, we still wanted it to be as resilient as possible. So it's a logically indefensible position. You say, wait a minute, you've asserted there's a logic error. How can you possibly write code to recover? But on the other hand, there's real users out there, and they have real data, and they don't want that data to be corrupted, and they don't want the app to crash. They want you to recover the best you can, and it actually works way better than it should in practice.
Yeah.
And but so if you follow that line of reasoning to its logical conclusion, you get something like Erlang, where you have lots of small processes that themselves are always self-consistent. If one of them has an error, the whole thing goes down, comes back up again. But the rest of the system of these cooperating processes is still alive. We don't really have that sort of facility in C++ unless we really design it in at a component level. So we don't really have the facility to be able to say, well, if an error occurred that we might consider a logic error, then we can recover from it. And that's really the crux of it. We might think we can, we might get away with it, but really we are just opening ourselves up to all sorts of problems.
Yeah, and this is relevant to expected as well, because the current proposal has dot value, which throws if there's no value. And Niall actually wrote a paper about this last year, I think, for concerns about expected after the boost.outcome review. And he's saying that actually still expected should have all the observers should be narrow contracts. Like if we're going to have vocabulary types like still expected, which could throw if you ask for the value and it didn't have one, like how are you going to recover from I need this data and you don't have it, and then suddenly I need to make all my code dynamic exception safe because this is a vocabulary type. I think that's very relevant for SID expected as well.
I actually love the throwing value, which optional also has, and I think variant as well, right? Because I think that does actually express the way that we want to use classical exceptions in C++. That fits very well with the classical model of I don't really, at the point where I get the expected back, I don't need to care whether it was a success or a failure. I'm just going to try to use it as if it was a success. And if it was a failure, it'll throw, which is what I want. On failure, I want to throw. Right. Or if I want something lower level and more, down in the nitty gritty to propagate it back as an expected, I can write code to do that. But by default, I get this nice sort of traditional classical behavior. Now, this has a problem for SG14, right? Because then as soon as someone uses value, as soon as someone uses that method anywhere in their code, suddenly you have to link in all the exception material, unless they consistently use star instead of value everywhere. If they slip up and write value once, you have to link in all the exception stuff. So they really don't like that.
Yeah, I think for the, like you're saying, like you want to program for the successful case and just if the exceptional case happened, then fine. I think something like, so if we're taking a library solution, then something like a monadic interface for SID expected would do that in certainly a lot more suitable way for kind of SG14 domains, where you just say, okay, well, I have all of these transformations which I want to make onto my the value which I hope this expected has stored. And if it doesn't, then you're just going to not do any of these operations, and you're just going to pass the error, the unexpected object through all of these transformations. I think as a library solution, that works very well. And then if you look at some of the like operator try proposal, which is also mentioned in Herb's paper, that kind of tries to take that idea and put it into the language using a kind of coroutines like way. I was thinking about this earlier. We need a better term for this kind of coroutine style error handling. I think we should call it "oh no" routines.
So,
I mean, an example of a term I might use, I don't think anyone else has used this, but in something about injecting control flow, right? Because that's what both co-await and this operator try are trying to do. They're saying, I'm writing something that looks like an expression, but secretly it's got a control flow edge, leaving this function that I didn't write. You know,
and that's what we call monads. It's the ability to take control of the bits in between.
And I think
we've dropped it. We've gone too far.
Well, if you follow that thread, you get to a nice monadic interface along the lines that Simon was talking about, binding these things together. And then you start to think, well, how can we make this a bit nicer in the language? And you look at, say, Haskell with its do notation, which allows you to write it as if it was just normal imperative code. But at the end of each statement, which is really an expression, that's when it does the monadic magic. There's a direct mechanical translation from that to Herb's proposal for static exceptions. That's almost exactly what it is. It's just baking that into the language. It's more specialized for error handling rather than a generic monadic interface. But that's really what it is.
So there's a very important topic that I think Herb brought up that I think a lot of people miss, and I was kind of surprised. A few years ago, somebody who works on Linux told me this, and he said, on a Linux OS, malloc is never going to return 0. And I was kind of surprised with that. And so, well, you mean because it's got virtual memory, so it's going to use disk space, but eventually that has to run out. I said, yeah, eventually that will run out, but it's still not going to return 0 on malloc. And what it does is it essentially, I think the term, I guess, is overcommits, but essentially it returns you a pointer to memory that cannot possibly exist, and you don't know that there's a problem until you try to use it, and then all hell breaks loose. You have,
it might exist, but it might not.
Right. It's possible that at the point where it allocates it, it doesn't exist, and then something gets freed, and now it exists again. Right. But the point is that the model we have is that you call new, and if it can't give you the memory, it throws an exception. And his point is that on Linux, which is how most people are writing software as some form of Linux today, that doesn't work. That model just doesn't work. And it's really bizarre that we twist our code so much because we say, oh, well, we're calling new, and so that might throw an exception. And in fact, it can't throw an exception for most of the way most of us are writing code. And he's calling that out and saying, and this, by the way, I remember talking to Doug Greger and Dave Abrahams about how this was done in Swift. And in Swift, they just say, if you run out of memory, that's unrecoverable. And in practice, that usually is unrecoverable. It's really hard to unwind. Imagine a situation where you have a Linux box and you have completely exhausted all your swap space. You really, really have nothing left. Your disk is completely full. There's no RAM left. Can you walk back from that? And the answer is probably no, you can't. In anything other than a fairly trivial application, that's just not going to work. And so that's embraced by Swift to basically say, we will always assume that when we ask for memory, we can get it. And that essentially a new, whatever Swift calls that, a new allocation will not fail. And of course, that's not actually true. You can get to a point where it will fail. But when you get to that point, all bets are off. It's the equivalent that we have of essentially blowing off the stack. we just don't recover from that. We don't expect you to be able to detect it, and we can't recover from it. If you walk off the stack, you're just dead. And that's the way they treat heap allocation. If you can't get heap allocation, you're just dead. And so Herb is asking, saying, should we move to that kind of model? And for most people, that makes a lot of sense to me. Problem is, we do in fact have some people, maybe a really small number of people, but they're working on systems in which they know they can run out of memory, and they handle that gracefully by expecting malloc to return 0 and walking back from it. And I'm not sure how you can support both models.
Yeah, sense? I mean, the thing that C++ lets you do is, like, not just can operator new fail, but, you know, we allow people to swap in their own allocators, right? Their own sources of memory. That, you know, if you're using your own source of memory, you might have a little memory pool, and you can totally detect when it runs out of memory. And so you might, what do you do in that case? Well, you can't return error through any other mechanism, like vector doesn't let you signal error from new in any other way, or from the allocator in any other way. So you have to throw. And so we have to be prepared for, vector pushback or vector reserve needs to be able to throw arbitrary user-defined exceptions, because that's what the allocator might throw. And so if you have to allow that anyway, like, why not allow operator new to throw? It only really makes sense to talk about non-throwing operator new if you can also write your own non-throwing allocator, which currently you can't do. The only way to signal failure is to throw. So that's all kind of wrapped up together in one big problem, which Herb's proposal, the paper, alludes to that background, but it certainly doesn't try to address it.
There's a couple of problems with talking about memory allocation in this context. The main one is that there are obviously different application domains, and they have very different ways of looking at this. So we've been talking about desktop and server type of applications where it's usually a pretty safe assumption that new is never going to throw, except some long running applications, as somebody on the chat was pointing out. And there are creative ways to allow for that. But then when you get to very constrained environments, then obviously embedded is one of those domains that are particularly interested in this proposal, because they usually have exceptions disabled. They very frequently have to deal with low memory situations, and their code is entirely written around the fact that allocations may fail, or that they don't even perform allocations in the first place. So you have this whole range of approaches that we need to handle in a single language, and that's what makes this tricky. And I think that's why Herb wanted to talk about heap allocations separately from the exception story. But it's a tricky one. And I think in Swift, one of the reasons that's also a difficult comparison is that although Swift is primarily targeted at mobile, it's mobile in the smartphone sense, which is a lot further from embedded than it used to be. So you don't generally get into the same situation there. But it also has a platform facility where, when it's running low on memory, it will actually go around and call callbacks to say, can you give us back some memory? So it will do everything it can to free up memory before it finally comes back to the code and says, no, you can't have it. So that's another reason why it's something that very rarely, if ever, happens in a way that you have to deal with.
I cut my teeth as a Mac programmer on a 128K Mac, and we had all sorts of games we played because we had to always expect, anytime you ask for memory, for the answer to be no. And so we build in reserves and do things like that so that you could guarantee to be able to handle that situation properly. And the model, as you say, it depends on the application domain. Some people are running on a server, and it's a completely different thing than an embedded situation where in advance that you have a very limited number of bytes, and you're just going to dance on those bytes the best you can. Very different kind of thing. There was one other thing that I wanted to call out in the paper. It's a really, really minor detail, but it really tripped me up. And it wasn't, I don't think it's actually in Herb's paper. I think it's in Niall's paper, talking about the error codes that Herb's paper is really based on. And that is that they're defining equality to not mean equality. They've defined an equality operator, which means rhymes with rather than equals. And I think we're going to regret that. I just think anytime you get away from the mathematical model of what you're doing, you're gonna regret it.
This is kind of a hot topic at the moment with span and a lot of talk about regular types and what should span be doing and what is expected for a single type and what is consistent. And yeah, it's a hard problem.
Right. But I think, to me, this is not a hard problem. Create a function called rhymes with and use that instead of equality, because equality should mean equality, not something like equality. And I think that it's just a mistake. It breaks down our ability to reason about things if you define equality, the equality operator, to mean something other than equality. The background here is, I'm sorry, what?
I said agreed, but I wanted to give a little bit of background on this.
Okay, please do.
That this is an improvement over the state of the art, which is STD error code that came in C++ 11. And I'm actually one of the authors of a paper that was presented in Albuquerque on problems with STD error code. No solutions, just the problems. And so Niall's work is trying to build on top of those problems and say, here you have a laundry list of problems, let me solve each of them one at a time. And he's made a solution that does address every single one of the problems in that paper. I'm not sure that it's really like a quantum leap, that it's the only way to solve them, but it certainly does tick all the boxes. And one of those problems was that STD error code, in the standard, there's STD error code and there's STD error condition. And when you compare an error code to an error code with operator equals, it does a what I call a trivial comparison. It just compares the elements, compare the code, compare the domain.
Which is what equality means.
Right. When you compare error condition to error condition, it also does that trivial comparison. When you compare an error code to an error condition or vice versa, so you're mixing the two types, you still use equal, but there it does the semantic comparison, which is what you're calling rhymes with. And this is horribly confusing to someone learning the system. I don't know how confusing it is to someone using the system, once they've got experience with it, but it's certainly a source of confusion for people reading this and going, what the heck is going on? Sometimes equal means equal, and sometimes it doesn't. So in Niall's proposal, he picks consistently, it means rhymes with. It never means equal. It always means rhymes. And so that's at least it's no longer inconsistent with itself.
So
it is the rest of the language.
Explain the error code has the error family. So it can be, let's say it's a POSIX
set. We call it domain.
A domain.
Yeah.
So it could be a Windows domain or POSIX domain. It could be anything. It could be your app domain. And then within a domain, it's not uncommon for there to be error codes that mean logically the same thing. So it means you don't have permissions to open the file, or we're out of memory, or we're out of disk space, or whatever. And so the idea is that when you compare two error codes, when you compare an error condition, which is the out of memory condition, with an error code, which is the domain plus that error, what the proposal is that the equality operator throws away the domain. It doesn't look at the domain at all. It only looks at what the condition is. And I think that's great functionality, but it shouldn't be spelled equal. That's my point.
And it doesn't throw away the domain. It actually gives a certain element of control to the domain, so that the domain is the only one who knows which of its error codes mean one thing or the other, right? So it's actually sort of calling a method of the domain for the domain to figure out whether it's equal or rhymes. And yeah, I don't think that it should be spelled equal. You mentioned string view. Simon mentioned string view has the same sort of problem going on right now, where it's actually in C++ 17 with an equal that doesn't mean equal. And one use case that I actually saw for that, because someone wrote to me and said, what about this, was you could actually store them in a map or an unordered map, and like make a map of all the different substrings of a string without having to make copies of them. And that would just work because equal equal and hash and so on string view are actually hashing the contents of the string. So you make a map of views where the keys are all views. And that's much cheaper than making a map of value strings. And this was kind of cool. I don't think that it by itself justifies making a non-regular operator equal equal. But it shows that when we choose operator equal equal, if we're going this sort of string view, sort of pragmatic, not really philosophical route of let's just take the thing that is going to help us write cleaner, not philosophically cleaner, but write shorter code, that lets us make a map of string views and whatnot. Right. That's a consideration for some people. Now, does the operator equal equal allow us to do anything cool? Is there a reason that we're picking this syntax because it lets us do cool things? I don't think so. But if there were, that might be a counter argument.
Yeah, but I think the more likely argument goes the other way, which is that it's more likely that we have some generic code, some template somewhere that uses equal equal to mean exactly what equal equal means. And if you have defined that to mean rhymes with, you're going to get bit, because logically you're going to find out that no, these are not substitutable. There's a difference between this and this. We just said they were equal because it was convenient. And I think we will rue the day. I think it's a bad idea. Anyway, out of the 3 papers, that was one little section that just hit my hot button, and I probably shouldn't have even brought it up because given the relative importance of everything else, but you know me, I'm a troublemaker.
I guess we should move on to econs next, shouldn't we?
That's right.
The important thing to note is it is a separate paper, so we can argue about that independently of the static exceptions paper.
But it also ties back into the static exception translation thing that I opened by complaining about, because there's this whole notion of what does it mean for this error to be equal to this other error? What the translation between, if I see, you would talk about that sometimes there are 2 different domains where the same error might show up in both domains, right? You have a Windows version of invalid argument, you have a POSIX version of invalid argument. But then even within POSIX, there may be errors where one is a subset of the other, right? You have one that's like input is too large, and then there's another one that says input is out of range, and then there's another one that says invalid input. And those are all generalizations of each other. If I'm testing against, did I get back an error code with value invalid input? Yeah. What if the error was actually input is too large? Do I want to catch that here, or do I want to only catch invalid, and so on?
I think you're making me say that equality is not the point there. What you want is some kind of function that says, does this map to this? And then you could even pass in an enum that says must map exactly, or maps close, or can be broader, or whatever. I mean, there's all sorts of ways you could make that work, and the equality operator is just not the appropriate way to do that.
One might even say integer error codes are not the appropriate way to do that. Maybe we need something where it's a set of possible problems somehow, or a bit set.
I tend to though be of the camp. I mean, when I first looking at APIs, I would look at all the errors and think about all the ways you would handle them, and it turns out most of the time you don't care what the error is. You just know you got an error. You're trying to print a document, it doesn't print. You tell the user it's not going to print. The error code might be useful for some troubleshooting thing, but the program itself is almost never going to actually do anything about the error code, right? I mean, if the reason it's not printing is because you don't have permissions, or the reason it's not printing is because the server's offline, all you're going to do is tell the user, couldn't print, and here's the reason. And it's not, the program is almost certainly not going to try to remediate that. Sometimes it is, which is why it's good that we have the error codes. But most of the time, it doesn't matter. It either works or it didn't, and we don't care. And this is one of the things that I learned in looking at exceptions, is we have all this mechanism for being able to throw any type of exception, and it turns out it's never important. The only thing that's important is, did it throw or not? It doesn't matter what it threw. That's almost never interesting. When you actually do some debugging or troubleshooting, I should say, okay, we're trying to figure out what it threw so that we can figure out how to fix it. But when you're writing the code, when you're executing the code, it's usually not important. surprise to me. I say I used to focus on, well, what would we do in this case, and what do we do in this case? And it turns out in almost every situation, we just tell the user we're not going to do what they ask for, and that's all you do. What else can you do, right?
It's interesting that std error code obviously came out of Boost error code originally, which came out of Boost ASIO and the file system APIs, but both examples of areas where you often do want to distinguish between the different error codes, and that's actually quite an important part of the API. So there's that. But yeah, the fact that it's an integral type, I think, is also really important, because that's a large part of what gives us the performance guarantees, determinism, and all the other good stuff about this proposal. But we also sort of want to treat it like we currently do with exceptions, where we can treat them effectively polymorphically through a sort of pattern matching syntax. So while we have multiple catch blocks to do that with dynamic exceptions, with static exceptions and error codes, we then have to do, well, as it happens, a series of if statements. And that's where I think the overloaded equals operator comes into it. And I tend to agree that maybe we shouldn't be using the equals operator for this, but I can see where the motivation is coming from. Good news is there's still time to fix it.
The functionality is perfect. I have no problem. There should be a function that is a rhymes with function. Probably shouldn't be called that, but maps to or whatever. That makes perfect sense. But if we're not talking about equality, then we shouldn't be using the equality operator. That's my nit to pick. So I have one question, and I don't know if you guys are really the right ones to answer. I don't know if anybody can answer. Maybe there's nobody. But that question is, if this proposal is adopted, is this going to win over the embedded community, the game community? Are they going to start using static exceptions? Do they want to use exceptions and just wish they could? Or is it like, exceptions, you guys you don't know how to test a return value?
Yes, most of the people that I know personally, so I work with LLVM a lot, so we don't use exceptions. And a lot of the people that I work with are kind of diehard, exceptions, bad, no, never. And some of them actually really like the idea of this proposal because their main arguments against dynamic exceptions are non-determinism and size of binary and runtime behavior when you actually throw and things like that. And this proposal addresses a lot of those concerns very directly. So from my experience, a lot of the people who are currently against dynamic exceptions quite like the idea of this new proposal.
And I'm definitely not qualified to answer this question, but I can imagine, that the embedded programmer in my head is asking two questions. Well, I guess the embedded programmer is asking one, and then another large group of no exception programmers is asking another. The first question is, does GCC 4.6 support it? And the other question is does Google's coding guidelines support it? And at the moment, the answer is no. But we'll see what happens.
We just have to give it a name which isn't quite exceptions, and then you can kind of sneak it under the code guidelines.
That is something that's being talked about.
Oh, yeah?
Just the name exceptions is something that puts a lot of people off, and probably it is a bit silly to fixate on that. On the other hand, as we said earlier, we have said in the past, use exceptions for exceptional cases.
Yeah.
And now we're saying, well, no, you can use this everywhere. So that's two good reasons that exceptions are probably the wrong name. But,
yeah, I do like the term disappointments.
Yeah.
There was a paper a while back about that. I don't know if that was the first use of it, but I quite like that term.
There was a good talk, it might have been a lightning talk, I forget, at CPPCon a year or two ago from someone in financial space. And they were pointing out that, for them, it's not about the exceptionalness of the, you don't care if this is the 99% code path or the 1% code path. It needs to be fast regardless, which is what we've been talking about with predictability and determinism. But it does mean that the name exception doesn't mean anything to them. I mean, a black swan event is exceptional, but you can't use dynamic exceptions to handle it because they're slow. It doesn't matter whether it's an exception or not. It needs to be fast. So the use case for this feature is not about exceptionalness. The use case is about just speed.
Yeah. But what I love is just, I know what code looks like when you can focus on the success path. In other words, you're not checking return types and things like that. The model of try catch is just results in much more beautiful code. And the fact that we didn't have a great way of implementing it meant that it could only be used in some of the code we wrote. And yeah, if we can get to a situation where we could pretty universally recommend and say, there's no overhead associated with this that you wouldn't have in just checking return types, or right. I mean, the same thing we say about all the other zero overhead abstraction things in C++. You couldn't write it better yourself. If we could say that, then I'm just so excited about this proposal. There's some things I hope we give it due diligence and not and get it right. And I'm
one thing that would contribute to getting it right, and something else that I think is a must-have for adoption, is benchmarks, which of course is hard when there's no implementation, which is not surprising because the paper's been out for a week. So but at some point, someone's going to have to sit down and implement this in a compiler with the new calling convention and so on, and then someone else is going to have to write a benchmark that actually looks at whether this is fast or not. And that's going to be a big hurdle, mainly because nobody's really done that for classical exceptions yet. One of the reasons that they remain slow, there are inherent reasons, but also there's no heat on anyone to make them fast. People avoid them because they're slow, and they're slow because people avoid them. So there's no market pressure to improve. And I know John McFarlane recently started a GitHub repository, whose name I don't know off the top of my head, but something short about exception handling benchmarks, which I think has currently one benchmark written by me, and it's about the sort of translation that this proposal is doing, of just saying what is the overall overhead if I have a function that does a throw, and then I catch that and turn it back into a return, and I detect that and turn it back into a throw. How much am I paying for each step? And the answer is a lot. Just getting that sort of benchmark of, if you write code using this new way versus the old way with error returns, which is faster. And if people start seeing benchmarks and see, one of the bars in the bar chart is 50% of the other one, they'll get a lot more excited about it.
It seems that the repository is called EHCT, Echo Hotel Charlie, whatever T is.
Yeah, I just posted it in the chat. And Simon, didn't you have a similar collection of data somewhere in one of your blog posts, or a call to collect it at least? Yeah,
it was. So Matt, I'm going to butcher your last name. I'm sorry, Matt Jubinski has a GitHub repo called CPP links, and it's categorized very well into lots of different sections. And there's one which is on error handling, so it has a lot of different blog posts and data on people who've done benchmarks and whatnot. So that's a good kind of resource to go and look at. And I think Niall Douglas also has benchmarks which he's worked on, which he's talked about at some of his conference talks. So there is data out there. But yeah, if we're actually going to standardize something like this, we need data on how this helps.
I think our best intuition at the moment is based on what little data we have about the relative difference between current exceptions and ADT-based error handling. Right.
And you would hope that if it's built in, then you'd be able to do more optimization, such as things you were talking about using special registers and whatnot.
So we've slammed past the end of the hour, and I try to keep these to an hour. Clearly, this is an important topic. Clearly, we have not covered it all today. I don't know if we will continue this next week. We will keep working to try to get Niall on because we want to pick on him. I mean, because he would have a lot of insight on this, and maybe we'll even get Herb to come on and talk a little bit about the paper. But I think, as I said, I'm not underestimating the importance of this paper in any way. This has a lot of potential to pull the community to get together in a way that other papers often divide instead of pull together. This is a really exciting development for me, and I'm really excited about it. I know we're going to continue to talk about this for a long time, and I'm really excited about this. Is there anything you guys want to close with before we say goodbye?
I just wanted to point out that somebody reminded us in the chat that the current nickname that's been going around is Herbceptions.
I like static exceptions.
I like static exceptions, yeah.
Yeah, I like that as well.
What's funny about it is that we've already had the term dynamic exceptions. It's like, that's really strange that we have something called dynamic exceptions and we've never had, you know, it's like somebody had to invent the opposite of that, right? Okay, well, I'm ready to wish everybody, thank you guys for all being on. I hope to have you back again. I hope your experience wasn't too painful for your first time here. What's that?
It was very nice.
Oh.
Yeah, thanks for having us.
All right. Well, it's great to have you guys on, and I want to wish everybody safe coding.
Safe coding.
That's forever.
Safe coding.
All right. Talk to you guys later. Bye.
Bye-bye.
Bye.
All right. That was